Hello, thank you for taking the time to look at the bonus question on the first exam of the 6 weeks. This question is a rational inequality and it's solved using what's known as a sign chart. Now we're going to talk about this in a lot more detail in a couple of weeks, but I wanted to go ahead and give you an idea. Let's just take a simple rational function like this. X plus 2 over x plus 3 has a vertical asymptote, x equals -3, horizontal asymptote, y equals 1, has an x-intercept of -2, a y-intercept of 2/3. Okay, so a pretty standard graph. Now, when you compare a rational function, or any function for that matter, to 0, whether greater than or less than, we look at that 0 being the x-axis, okay, because that's where y is equal to 0. So if the graph is above the x-axis, that's where we consider it to be positive. If the graph is below the x-axis, that's where we consider it to be negative. Now, on your sign chart, you're going to put two kinds of values. You're going to put any discontinuities you have. Here we have a vertical asymptote at -3, and you're going to put any x-intercepts. In this case, we have -2. So those are the values that are going to be going on my sign chart. Okay. Now, even though this has equality, I will include the -2, but I will not include the -3 because it's a vertical asymptote. The function's undefined at that value. And, there's more that we're going to go ahead and do, but I'll, explain later when we get there. But you'll take a look at the graph. Anywhere the graph is above the x-axis, this portion is above the x-axis, this portion is above the x-axis. Okay? Any portion that's below the x-axis, okay, right here, like that. So anything above the x-axis is considered positive. Anything below the x-axis is considered negative. Well, you'll notice the sign chart is describing exactly what is happening graphically. The graph's been divided by the discontinuity and the x-intercept. So if you'll notice, to the left of -3, that portion is above. So that would be considered a positive. Between -3 and -2, you'll notice the graph is below the x-axis. So that would be considered a negative. And then from -2 to infinity, the graph is above the x-axis. So that's considered a positive. So that's what the sign chart is doing. It's trying to describe exactly what's happening graphically. It's a way of finding solutions for your inequality without having to look at the graph itself. Okay, now having said that, let's take a look at this problem. Okay, 4 over x minus 6 plus 2 over x plus 1 greater than 0. Okay, well, the first thing, we always want it compared to 0. So we're going to go ahead and say greater than 0. Okay, we want everything on the same side, but we want to go ahead and combine these into one single quotient, okay, one single fraction. So a common denominator would just be a product of these two. All right, so my common denominator has to be x minus 6 times x plus 1. We're going to have to do a little bit of algebra to get these guys together. So 4 over x minus 6. Okay, well, I need to get that to the denominator I want, so I'm going to multiply by x plus 1 over x plus 1. This right here, anything divided by itself is 1. If you multiply a value or an expression by 1, it remains the same. So I'm not wanting to change the value of this expression. I just want to change the way he looks. Now we have plus 2 over x plus 1. Well, what we're missing here is the x minus 6. Okay, so let's see here. I'm going to go ahead and distribute across the top. So that would be 4x plus 4. Okay, over x minus 6, x plus 1. Okay, then we have plus, distribute here, 2x minus, 2 times x minus 6. 2x minus 12, again over the common denominator, x minus 6, x plus 1. Now that I have the common denominator, I can combine them into one single fraction. So I'm going to do this all in one step. So x minus 6, x plus 1. So it looks like we're going to have 4x plus 2x will give me 6x. 4 plus negative 12, so that's a minus 8. All right, so we've combined them into one fraction, and this is greater than 0. Okay. Now, this isn't an absolute, but the values that are going to make x 0 in the denominator, those are your undefined values. The majority of the time, they're going to be vertical asymptotes. It's possible they could be a hole, or what we call a removable discontinuity, but we're going to talk about that later. Okay, so I'm going to go ahead and take the expressions in the denominator, and I'm going to set them equal to 0. X minus 6 is equal to 0. X plus 1 is equal to 0. So x equals 6, x equals negative 1. If I were to graph this particular function, both of these would become vertical asymptotes. Okay? The majority of the time, the values that make x 0 in the denominator will be your vertical asymptotes. Not all the time, the majority of the time. I'll show you when there's going to be holes later. Now, the values of x that make the numerator 0, those are your x-intercepts. And see, for the sign chart, this is exactly what we need. We need to know where, if anywhere, there are vertical asymptotes and x-intercepts. So I'm going to go ahead and say, okay, 6x minus 8 is equal to 0. 6x equals 8. X equals 4/3. Okay. So these are the values that I need to go ahead and use on my sign chart. I need these two vertical asymptotes, and I need this guy right here. Okay, so I'm going to come up, and then we want to make sure that they're in the correct order. So this line right here represents my sign chart. I'm going to say negative 1. We had a positive 4/3, and then we had a 6. We always go in order from least to greatest. Now, the two values that came from the denominator, those are my vertical asymptotes, so I cannot include those. There's no inclusion on this problem anyway, but I'm definitely going to put open circles on both the 6 and the negative 1. Now, the 4/3 isn't going to be included either, and again, because it's strictly greater than. So these are all open circles. 4/3 is what we call the 0, and negative 1, negative, or should be 6 are what we call the undefined values. Okay, so now all we need to go ahead and do is figure out in these 4 intervals that we've created, which ones are positive, which ones are negative. And we're going to do that by simply choosing a value and plugging it into our function. Let me recopy this function up here. We ended up with 6x minus 8 over x minus 6 times x plus 1, and that's greater than 0. Okay, so let me show you what I mean when I say we're going to go ahead and choose a value. Like, I need some value of x between negative 1 and 4/3, but it can't be those values. I want to know what's happening between them. So 0 is a perfect value. So I'm going to take that value of my choosing, and I'm going to plug it right into this function. Okay, so for example, 6 times 0 minus 8, that would end up being a negative number. Now, you can go ahead and calculate the actual final value if you'd like, but we refer to these as sign charts. The only thing we're really interested in are the signs. So the numerator, 6 times 0 minus 8, that would give me a negative over. And you'll see I'm going to mimic the quotient. I'm going to replace those groups with their signs. So 0 minus 6 would give me a negative. 0 plus 1 would give me a positive. Okay, you just simplify. Now, of course, you can go ahead and simplify further, but it looks like we have a negative divided by negative, which ultimately gives me a positive. So if I were to look at the graph of this function between negative 1 and 4/3, that portion of the graph should be above the x-axis. Let's try another one, 4/3 and 6. So on this interval, let's choose, oh, I don't know, let's go 3. 3 sounds like a good one. Okay, so now that value I chose, we're going to plug in one at a time to these 3 groups, my function. So 6 times 3 is 18 minus 8. Well, that would give me a positive number. Over 3 minus 6 would give me a negative. 3 plus 1 would give me a positive. So it looks like I'm going to have a positive divided by a negative. So between 4/3 and 6, the graph should be below the x-axis. I ended up with a negative. Remember, if it's positive, it's above, negative if it's below. All right, let's do something greater than 6. Okay, it could be 7. You could even choose something very close to the value if you want, or you could choose something far off. The nice thing is it does not matter what value you choose on the interval. So let's see, plug it now in the same thing. 6 times 7 is 42 minus 8. Well, that will give me a positive number. 7 minus 6 is a positive number. 7 plus 1 is another positive. So a positive divided by a positive. So I know everything greater than 6 on this graph has to be above the x-axis. And we have 1 left, negative 1. Okay, so in this interval, what do we say? Plug in negative 2. Okay, so 6 times negative 2 is negative 12 minus 8. That would be a negative number. Negative 2 minus 6 would be a negative number. Negative 2 plus 1, that would be another negative number. Okay, so two negatives are going to give me a positive. A negative divided by a positive is a negative. So to the left of negative 1, this graph should be below the x-axis. See, we really know quite a bit more information about the graph than is realized. We don't see the graph itself, but we know exactly what has to be happening. Now, how does this help me get my answer? How does it help me solve the inequality? Well, it depends. That's why we always compare it to 0. If you're greater than or equal to 0, your solutions will be all the positive intervals. If it's less than or equal to 0, then it's going to be all the negative intervals. Because this problem is greater than 0, I want all the positive intervals. So I know values of x that would make this true are going to be here and here. Now the sign chart is the work. Your final answer is to write those regions as interval notation. So this first interval would be from negative 1 to 4/3. Let me erase this. Don't need it anymore. Both parentheses because they're open circles. Union the other interval which starts at 6. And that would be my solution. All values of x that would make this a true statement. Now, don't worry if some of this was confusing. We're going to be spending more time, as I said, in about a week and a half talking about this in detail. But again, thank you for taking the time to walk through this problem with me. Have a great day.